Well, hi there, and welcome back to day 2 of working with maximum and minimum values using the candidates test to find those extrema. What we're going to do a little differently today is expand on yesterday and something called an implied domain. What this means is that we're not working with a closed interval anymore. We're not given the point A at the beginning and the point B at the end, but rather we have to figure out if there are endpoints of an interval on our own. So that's what we're going to be working on today. So let's take a look at reviewing domain and what it means to have an implied domain. So this deals with the question, what if an enclosed interval is not explicitly given? In other words, an A, comma, B interval, what if we don't have that? It's not specified in the problem. Well, then we've got to go to what's called an implied domain. And so this goes back to things like all real numbers and what the domain is for a problem. So if we do have all real numbers, it means there are no endpoints for us to check. Okay, so yay, we don't have to worry about that. We can kind of like check that off the list, and there's no endpoints to check if the domain is all real numbers. But if it's not, so how do you know if it's not all real numbers? So 3 things to look for. Does the function have a denominator? If so, the domain is not all real numbers, and you'll have to figure it out. And remember, denominators are never equal to 0. That's one of the rules. You shall not divide by 0. You shall not have 0 in the denominator. All right, if the function has a logarithm, that's another case where it's not all real numbers. And those always must stay greater than 0. And then the last is, does it have an even radical? And even radicals must be not just greater than, they must be greater than or equal to 0. So those rules, these 3 domain rules, are going to affect the implied domain. And so we'll use that to help us test our endpoints. All right, so let's see how this actually works in real life or in a real example. Find the absolute maximum and minimum values of this following cubic function, and there are no endpoints. Okay, no endpoints at all given, no interval given. All right, so let's tackle this first question, and then we'll talk about the critical points. Okay, the endpoints. Now, let's think about the domain. Does this problem have a denominator? Does it have an even root? Okay, and by even roots, I mean like square roots, 4th roots, 5th root, 6th roots, etc. Or does it have a logarithm? And the answer to this is no. And so the domain for this one, the implied domain, is all real numbers. That basically means that point A is negative infinity and point B is positive infinity. Okay, I mean, these are, there is no beginning because it's infinite. There is no end because it's infinite. This is what all real number means. Now, do these have y values that go with it? Okay, well, if I plug negative infinity into this question, is that possible to do? If I plug positive infinity into this question, is that possible to do? So we're going to think about that. We're going to come back to that for its y values. Okay, let's move on to the critical points. Critical points have to do with the derivative, so we'll find our derivative. 3x squared minus 6x plus 3. We are going to set this equal to 0 while we factor it. So I can take a 3 out because it's 3 in common. That's x squared minus 2x plus 1. I could factor that into the star factors x minus 1 and x minus 1, and I'll set that equal to 0. Setting that equal to 0 gives me x equals 1 as my critical point. Now I need the y value to go with that, right? So what would y equal? So we're going to take x is 1, and we're going to plug it back in to all these places. Okay, so we'll put 1 in there. So 1 cubed minus 3 times 1 squared plus 3 times 1 minus 2. That turns out to be a y value of negative 1. So we have a y value of negative 1. Oh, let me erase this line here. All right, get rid of that. Okay. Then, as we practiced yesterday, we'll also set our derivative equal to 1 over 0. So 3x squared minus 6x plus 3. We'll set that equal to undefined. Cross multiply there. And that gives me 1 equals 0, which doesn't exist, so there are no critical points. All right, so what are the absolute maximum and minimum values? So we need to know these y values. So we already know about this combination there, x is 1 and y is negative 1, but let's go back and think about what will these be. You're going to have to think back to what you know about how this graph is shaped. Okay, this is a cubic graph. Cubics are those snake-shaped graphs. Cubics look like this. Okay, so that cubic goes forever up and it goes forever down. It never gets to a highest point, it just keeps going higher and higher. It never gets to a lowest point, it keeps getting lower and lower. And so their lowest value is negative infinity and the highest value is positive infinity. It's like the range. Okay, the range of this problem, remember when we talked about range? From negative infinity up to positive infinity, the lowest to the highest. Okay, this function does not have a maximum or a minimum absolutely. It has a local, which I circled in green. Okay, this one is, I'll label it here. That will be a local, but it will not be an absolute. So to summarize, an absolute max, there is none for this problem. And for an absolute min, again, there is none. Why? Because the implied domain of this problem is all real numbers, and there is no low value and there is no high value, absolutely. There is a local one, but there is not an absolute. Okay, let's try another one. Find the extreme value, so that means the absolute max and min of this problem. All right, so once again, we need to think about endpoints. We need to think about critical points. For the endpoints, because there is, excuse me, no given interval, we've got to figure out the domain ourselves. Now this domain does have a denominator and it does have a square root. And so we need to take what's in the denominator and under the square root and find the rules that say it has to stay greater than 0. So we're going to do the math on this to figure out where the endpoints might be of this problem. So we square both sides. So 9 minus x squared is greater than 0. You're going to subtract 9. We have negatives on both sides, so we divide by a negative, which means, don't forget, flip the sign. And then we're going to square root. And when you square root, you have to remember there's not just a positive 3, but there's also a negative 3. So when you have a plus or minus, the negative goes on the left and the positive goes on the right. So now we have our endpoints of the interval. Negative 3 is the left endpoint, and positive 3 is the right endpoint. Okay, so we've got our endpoints set here. So when x is negative 3 And when x is positive 3, we need to find the y values that go with that. All right, so let's plug negative 3 back up into the original problem. So that would be 1 over the square root of 9 minus, now if we plug in negative 3 and square it, we get 9. 9 minus 9 is 0. That's 1 divided by 0. And remember, we learned last semester that 1 divided by 0, if it's a positive number, is going to be positive infinity. So this turns out to have an endpoint of positive infinity. Same thing is going to happen when you plug in positive 3. We get the exact same result. So we get positive infinity again. That means this graph is going up and up and up and up and never stops going up. Both sides of this graph go up. All right, let's talk about critical points. So now we need to have f prime. Okay, now before we find the derivative of this, I'm going to suggest that you go back to the original and write it with parentheses instead. So 9 minus x squared. Because it's a radical, it'll be a half, and the radical's in the denominator, so you should have a negative. So I would write it that way so that you can do your derivative. So remember, derivatives are you pull the power to the front, so negative 1/2 in the front. You leave the inside alone. You subtract 1 from the power, so negative 3/2, and now you've got to remember the chain rule, because this is the square root of, and we say of, which means we remember the chain rule, which is negative 2x. So let's clean that up. Into the denominator is going to go 9 minus x squared to the positive 3/2. And the numerator will still have the negative 1/2 that was pulled to the front and the negative 2x. So those double negatives will make a positive, the 1/2 and the 2. So double negatives make a positive here, the 1/2 and the 2. So we're left with x by itself in the numerator and 9 minus x squared to the 3/2 in the denominator. Okay, so now we're going to take that and set it equal to 0 and 1 over 0. So x over 9 minus x squared to the 3/2 equal to 0. Probably put it over 1 is better. And then x over 9 minus x squared to the 3/2 equal to 1 over 0. So let's cross multiply and solve both of those. So when I cross multiply, I get x equals 0. And I'm going to plug that back in to my original problem. So I'll put 0 in, so I'm going to get 1 over the square root of 9 minus 0, which is 1 over the square root of 9, which is 1/3. 1/3 is a pretty low number, pretty small. Then I'll cross multiply this. And when I cross multiply that, I will get 9 minus x squared to the 3/2 equals 0. And I solve that all over again. I don't need to do the math. I've already done it once. I'm going to get plus or minus 3. And we already know that plus or minus 3, the y was positive infinity for both of those. So now can I find an absolute max or an absolute min? All right, so the absolute max. Do I have a highest value? Well, I've got infinity, okay, which just means that this graph is going up, 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 up. So the absolute max is none, because this graph just keeps going up to infinity. But the absolute minimum, I do have a smallest number, and the absolute minimum is 0, 1/3, and that was this value that we got here, being the smallest number that you would have, way lower than infinity. Okay, just one more example. finding the extrema, the absolute maximum minimum of this equation here. All right, so endpoints once again. All right, the endpoints. This does have a square root, and so again, I need to take just the square root. Okay, I don't have to worry about the x right now because that's not the problem. It's always just the denominator or an even root or the part of the logarithm. And so this is just the square root part I have to worry about. Greater than or equal to 0. Okay, we'll solve this by squaring both sides. I'll subtract 16. I see a negative on both sides, so I divide by -1, which turns the equation around. I have plus or minus 4 when I do the square root. So we have 4 and -4 as our endpoints. So now I'm going to plug x is 4, and I'm going to plug x is -4 back into the original to see what the y is to go with both of those. So when I plug x is 4 back into the original, I get 4 times the square root of 16 minus 4 squared. That turns out to be 0. And when I plug -4 into that, I get -4 times the square root of 16 minus 16, which is also 0. So for both of them, I get 0. So that's a tie. They're both the same. I don't know if those are mins or maxes yet, but they both are 0. All right, now our critical points. Okay, so I just want to, again, remind you about how to do the derivative here. So we're going to do f prime of x. This original problem is a product. This is x times, and I would encourage you to put the times in there and to put it as a parentheses, 16 minus x squared to the half. Okay, so we want to recognize this as needing our product rule. So we're going to call this the part A, and then we're going to call this part B of our product rule. So remember, the product rule says start with B, and then A prime, and then A, and then B prime. So let's work through our product rule. So B is 16 minus x squared to the half times A prime, which is 1. Plus, now A, which is x, and B prime. Okay, our B prime is move the half to the front, leave the inside alone, lower it to -half, and remember the chain rule of -2x. So that is our whole product rule. Okay, so what we're going to do now is clean up this so that we can set it equal to 0 and set it equal to undefined. So this is the square root of 16 minus x squared plus, all right, all of this combines. We've got the square root of 16 minus x squared in the denominator, and the numerator is -x squared. Okay, that's realizing that we can take this half and that 2, but we still have a negative and we still have a couple x squareds. Now before I set this equal to 0, it needs a common denominator because this part is over 1, and I need to make the common denominator match. And so I'm going to multiply by rad 16 minus x squared on the top and bottom. So that will give me 16 minus x squared in the numerator plus another -x squared, and the common denominator is rad 16 minus x squared. So if I simplify that, I'll have 16 minus 2x squared over regular 16 minus x squared. Now the 16s don't reduce because this is a subtraction problem. The x squareds don't reduce. What I want to do is set that equal to 0 and equal to undefined. So I'll take 16 minus 2x squared over the square root of 16 minus x squared and set it equal to 0 over 1. And I'll also set that equal to 1 over 0. So I'll be ready to do my cross multiplying. All right, cross multiply. What will that give me? That will give me 16 minus 2x squared equals 0. And then subtract 16 from both sides. And divide by -2. And square root. So x is the plus or minus square root of 8. Now I need a y value to go with both of those. So if I plug the square root of 8 positive into the original, okay, if I plug, so I'm going to go back to the original problem, plug in the square root of 8, I'm going to get 8 and -8. Okay, now let's do the undefined part. We cross multiply, and that will give me rad 16 minus x squared equals 0, which I've already solved, and that will give me x is plus or minus 4, which I've already plugged both of those in and gotten 0. All right, so to summarize all of this, let's look at the y values that we have. We need the absolute max and the absolute min. And I can see what the absolute max and min are going to be. So I've got my absolute max is the highest, and the absolute max is rad 8 paired with 8. Now, that was the highest number. And the absolute min is negative rad 8 paired with -8. So the 0 ends up to be what we call a local. It was not the absolute. Now sometimes when you're all done, it helps to sort of peek at the picture of the graph and to see what it looks like visually, so that to see if it makes sense. And this graph looks like this. And so we've got -4, 0 here, which is an end point, but it's not an absolute. And then we have 4, 0 over here, which is another end point, but not an absolute. And so our absolutes end up to be right here. And that's the negative rad 8, -8 point. And then the other absolute max ends up to be positive rad 8 here. So sometimes I do like to visualize just to make sure to kind of double check my math, right? To make sure that I haven't made a mistake back in my math part, to make sure that the graph matches. All right, so you have some algebra work to do here for domain and helping you find your endpoints, and also some calculus to do with the derivatives and helping you do the different product and chain rules that we have with our derivatives. All right, so we'll come back on Wednesday and we'll tackle any questions that you've got left on the extreme values and how to use the candidate test to find them. All right, see you then.